Hi friends, I am Sahil Wagmare, SE Mechanical student of VPKBIET Baramati, presenting before you the new technologies in IC engine. Introduction. Various engine systems have been developed in effort to improve the engine performance and fuel economy of an automobile. The engine will either have powerful performance or increased fuel economy, but with the existing technology, it is difficult to achieve both simultaneously. The conceptual development, design, manufacture, and analysis of piezoelectric control hydraulic actuator was developed for a use as a replacement for the camshaft in an internal combustion engine. Its development results in a new device called the camless engine. So, what is camless engine? A camless engine uses electromagnetic, hydraulic, or pneumatic actuator to open the puppet valves. Actuator can be used to both open and close the valve, or an actuator opens while spring closes it. Ability to achieve truly variable valve timing in each cycle. Explanation. They are composed of two superimposed electromagnets between which moves a metal part that is interdependent with push rod. Electromechanical actuators are placed at tail end of the valves. Management units send command to the electromagnets which alternatively attract the moving component, that is push rod. Once the solenoid gets actuated, the rocker actuates and compresses the valve and valve spring, which in turn releases the flow of air into the engine cylinder. Here we can see the diagram of a camless engine and also the block diagram. The types of camless variable valve actuating system have been developed and can be classified into two types. One electromechanical and second electrohydraulic. So we are interested to study electromechanical system. Electromechanical actuator commanded by a distribution management unit control the movement of the valves. There is therefore no longer any direct mechanical bond between valves and the crankshaft. Camless valve variable timing is electronically operated by a microcontroller which control electromechanical rotary solenoid actuators. The requirement of force and speed needed from a solenoid in order for this system to be effective, rotary solenoids meet the requirement for this system. Each of these solenoid will be connected to the intake and exhaust valves, relieving the engine of load of a cam system. Depending on the load and engine speed, the microcontroller which will process the information given and use pulse speed modulation, that is PWM, to actuate the solenoid valves. This PWM will generate square wave that are identical to timing profile for the most efficient engine at particular speed and load combination. This PWM will be sent to solenoid to actuate the timing of this device. Once solenoid is actuated, the rocker actuates and compresses the valve and valve spring, which in turn releases the flow of air into the engine cylinder. This generated PWM are predetermined square waves that will be hard-coded and referenced by a microcontroller depending on the load and speed of engine for maximum engine efficiency. Advantages of electromechanical. By use of this design, the flow of air through the engine cylinder can be directly controlled by microprocessor to supply the engine with precise amount of air at designated engine speed. As a result, the valve lift and timing events of the valve train are experimentally balanced to gain largest amount of engine performance while limiting fuel consumption. The results show that this design would improve the fuel economy of an engine by 2.3% overall compared with Honda VTC, ranging from high 6.5 at engine idle to low 0.3% at mid-range speeds. Benefits: more torque is made available, optimum volumetric efficiency, increase engine performance, decrease fuel consumption, decrease harmful emissions, cylinder deactivation, increasing durability and engine life. Its applications are in automobile, heavy vehicles. Reverse operation is advantageous in marine equipment having dual out drives or T drives. In conclusion, camless engine provide a great development in an IC engine and marks the beginning of second generation engine. However, the future is not necessarily rosy. There are many problems to be overcome with electronically controlled valves. The problem lies not only in the software required, but also the mechanisms of actuators. Coil transistor response times and saturation effects at high RPM are just some of the issues. Next technology is KERS. KERS means Kinetic Energy Recovery System. KERS store energy when vehicle is in braking and return it when accelerating. During braking, energy is wasted because kinetic energy mostly converted into heat energy or sometimes sound energy that is dissipated into the environment. Vehicles with KERS are able to harness some of this kinetic energy. In doing so, will assist in braking. By a touch of button, the stored energy is converted back into kinetic energy, giving the vehicle extra boost of power. KERS is a collection of parts which takes some of the kinetic energy of vehicle under deceleration, stores this energy, and then releases the stored energy back into the drive train of a vehicle, providing a power boost to that vehicle. For the driver, it is like having two sources at his disposal. One of the power source is engine, while the another is stored kinetic energy. Basic elements of KERS. First, a way to store and then return energy to the powertrain, and second, a place to store this energy. In essence of KERS system is simple. You need a component for generating the power, one for storing it, and another to control it all. Thus, KERS system have three main components: the MGU, the PCU, and the batteries and flywheel. Here is the block diagram of KERS system. Working principle. Basically, its working principle involves the storing energy involved with the acceleration and using it for acceleration. That is, when a car brakes, it dissipates a lot kinetic energy as heat. KERS tries to store this energy and convert this into power that can be used to boost acceleration. A standard KERS operates by a change cycle and a boost cycle. As the car slows for a corner, an actuator unit captures the waste kinetic energy from rear brakes. This collected kinetic energy is then passed to a central processing unit, CPU, and on to the storage unit. The storage unit is positioned centrally to minimize the impact on the balance of the car. Advantages of KERS: high power capability, lightweight and small size, long system life of up to 250,000 kilometers, completely safe, a truly green solution, high efficiency storage and recovery, low embedded carbon content, low cost in volume manufacture. Conclusion: it's a technology for present and the future because it's environment friendly, reduces emissions, has a low production cost, increases efficiency, and is highly customizable and modifiable. Adoption of KERS may permit regenerative braking and engine downsizing as a means of improving efficiency and hence reducing fuel consumption and CO2 emissions. The KERS have major areas of development in power density, life, simplicity, effectiveness, and first and foremost, the cost of the device. Applications are being considered for small, mass production passenger cars as well as luxury cars, buses, trucks, etc. The next technology is SCCI engine. SCCI means high compression combustion engine. SCCI is a form of internal combustion in which the fuel and air are compressed to the point of autoignition. That means no is required to ignite the fuel and air mixture. Creates the same amount of power as a traditional engine but uses less fuel. How does it work? A given concentration of fuel and air are spontaneously ignited when it reaches its autoignition temperature. The concentration as temperature can be controlled by several ways. High compression ratio, preheating of induction gases, forced induction, retaining or reintroducing exhaust gases. Unlike the conventional engines, the combustion occurs simultaneously throughout the volume rather than in the flame front. This important attribute of SCCI allows combustion to occur at much lower temperature, dramatically reducing engine out emissions of NOx. There are different challenges we are facing nowadays. There are emissions, that is NOx and soot. Also the fuel economy. The fuel consumption is increased by more than 10% in last 7 years. Here, the diagram shows comparison with other engines of SCCI engine. Its potential is high efficiency, no lock limit on compression ratio, low PM emissions, no need of PM filter. SCCI provides up to 15% fuel savings while meeting current emissions standards. SCCI engine can operate on gasoline, diesel fuel and most alternative fuels. In regards to CI engine, the omissions of throttle losses improves SCCI efficiency. Disadvantages: higher cylinder peak pressure may damage the engine. Auto-ignition is difficult to control. SCCI engines have a smaller power range. Its barrier are auto-ignition event is difficult to control, unlike the ignition event in spark ignition and diesel engines, which are controlled by spark plugs and in cylinder fuel injectors, respectively. SCCI engines have small power range, constrained at low loads by lean flammability limits and high loads by in cylinder pressure restrictions, high SC and CO emissions. The future of SCCI. The future of SCCI looks promising. Major companies such as GM, Mercedes-Benz, Honda, Volkswagen have invested in SCCI research. Primary prototype figures shows that SCCI car can achieve in the area of 43 mpg. The next technology is OPOC two-stroke engine. The OPOC means opposed piston opposed cylinder technology, developed by Ecomotors International, a startup based in Troy, Michigan. According to company, the two-stroke engine is up to 50% more efficient vehicles and pollutes far less than a conventional two-stroke engine. Here we can see the diagrams of opposed cylinder, opposed piston arrangement. This one also same. The engine uses 2 piston movements per cycle instead of 4, and each cylinder contains 2 opposing pistons instead of 1. A single crankshaft sits in between pairs of cylinders. A design relies on precise computerized control of all the components. When outer piston moves away from the center of cylinder, the inner piston moves in opposite direction, resulting in opening of intake manifold. The fresh air enters into the cylinder. Then the piston travel near the center of cylinder, compressing the air. The temperature of air increases. At the time fuel will be injected, the combustion takes place. When expansion takes place, exhaust manifold will be open. Before inlet manifold opens, then the burn gas will start to escape. Addition to that, when inlet manifold opens, scavenging process takes place. Advantages: high power to weight ratio, high power to volume ratio, use of variety of fuels including gasoline, diesel, natural gas, GP8, hydrogen, assisted SCCI combustion using proprietary diesel fuel system, conventional parts, materials and maintenance. Difference between common engine and OPOC engine. Piston moves till TDC. Piston moves only till center of cylinder. Only to one piston inside cylinder, two piston inside cylinder. Less efficient, more efficient. Sensor are required and important. Electrical clutches is absent. Electrical clutch is present. One cylinder on one crankshaft consists two cylinder on either side of crankshaft. Thank you.